air end is a two-stage oil-free compressor unit. Both compression stages comprise male and female rotors with a special protective coating. There's no physical contact, either between the matched rotor pairs or the rotors and the air end casing. Everything is separated by a precisely engineered air gap. The male rotors of both the first and second stages are driven by a single main gear at the back of the air end. Helical timing gears at the front of both sets of rotors ensure perfect synchronization is kept between the rotor pairs at all times. This means no oil is needed to seal the compression process, making this air end a perfect solution where oil-free compressed air is a critical requirement. Oil never enters the compression chambers, but is used to keep gears and bearings lubricated and cool. Special seals between the rotors and bearings prevent air passing into the oil system and oil passing into the compression chambers. Hot oil drains to an oil reservoir located below the air end via two oil return pipes. The hot oil is then pumped to a cooler and returns to the air end via an oil filter. A pressure relief valve fitted to the front of the air end ensures that oil pressure doesn't exceed 2.5 bar or 36 psi. Oil is topped up via a filler pipe at the front of the air end. The compression process is kept cool by a constant flow of water passing through channels that surround the air end rotors. Heat transfers to the water, which is then pumped through an external cooler before returning to the air end. Air enters the first stage via the air intake valve and is trapped between the lobes and flutes on the underside of the compression rotors. As the rotors turn, the volume of the trapped air reduces, compressing the air and driving it towards the delivery port at the back of the air end. After leaving the first stage, the compressed air passes through a pulsation damper, then onto a first stage or interstage cooler. This can either be air or water-cooled, depending on the model of compressor. It's important to cool the air before it enters the second stage, as hot air will have expanded. When cooled, the air contracts, providing a greater number of air molecules in the same volume. This results in more efficient second-stage compression. The cooled compressed air passes through a moisture separator, then on to the inlet port of the second stage. The volume of the air is greatly reduced after first stage compression, which means that the size of the second stage rotors can be smaller. The second stage further compresses the air to the required pressure in the same manner as the first stage. However, this time the compression process takes place on the upper side of the rotors. The compressed air exits the air end via a delivery silencer, then through a non-return valve. The air then passes through a final second stage air or water cooling process to ensure the delivery air is at the right temperature. Then, after a final journey through a moisture separator, the air is ready to exit the compressor at the delivery port.